So we're going to start working into some probability rules. The only thing we've talked about so far is simple probability and the complement of that. We're going to today look at something called the addition rule, which we need to apply in certain probability problems. There's different ways the problems can be shown. And we're going to look at three different ways. One is with a Venn diagram, like you see here, where you have circles that usually overlap. They don't have to. Okay. Then we're going to look at a table, a very simple table. And then we're going to look at something that we looked at earlier in the year, a two-way table. And all those situations, we can describe the addition rule for probability. But before that, I want to talk about being familiar with the words union and intersection. It's when we talk about certain situations. So for each of these following probability expressions, okay, take notes on what the notation means. Shade the Venn diagram. So if I ask to find the probability of A, well, it's really nothing to take notes on. It's just event A occurring. What would that look like visually? If I had two events that overlapped, it would just look like this. Similarly, if I wanted to find the probability of event B, that would mean event B occurring. And I would shade the entire circle B. So notice in those situations that in the first one, part of A also included some other event B happening. Okay. What about not A? And that's what that little C means, not A occurring. What would you shade here? Just this section?
Yes.
Right. That's not A occurring. Or another way you could say it is B only occurring. Okay. All right, here's where we get into some notation. The upside down U. In set notation and in probability, that means and. So this means events A and B occurring. They both must occur. How would you shade that? Just this middle part here. If we've got a right side up U, that means or. So A or B can occur. Could be both of them at the same time, but it doesn't have to be. If it's just A, that's good enough. If it's just B, that's good enough. If it's both of them, that's good enough. How would I shade that? Yeah, everything. Like so. And then finally, what would this mean? Not A or B. So now that I show that, well, I'd actually have to put in a rectangle like this to show that it's going to be everything outside the two circles. Like so. So I just wanted to be familiar with some notation, what it means, specifically and or, as well as how we can show these things visually. We haven't seen these yet. We've done tables, but we haven't seen that diagrams yet. So, speaking of data, the OkCupid data set. So this data set, public online dating profiles from 2012 on a site called OkCupid. Filtered for people who identified as age 36, male, heterosexual, living in the San Francisco area. So after filtering, collected data for each profile that reported their height and yearly earnings, and it came down to these 4 characteristics. Okay? They were either shorter than the median height or taller than the median height, and they earned less than the median amount income that they all earn together, or they earn more than the median. So they're classified in 4 categories. We've got a short low earner, tall low earner, short high earner, tall high earner. And this is how many they found, 192. And how they were broken up. So out of the 192 that were 36 and male and heterosexual living in San Francisco, 21 of them were considered short low earners. 22 were considered tall low, 48 short high, 101 tall high. Okay? And so here's all the probabilities that we would select one of the 4. Is this a valid probability model? Do you remember the 2 conditions it has to meet?
Add to 1.
These all have to add to 1. And they do. All probabilities add to 1. Because if they didn't, something's missing and we can't answer the questions correctly.
And they have to be between 0 and 1.
Between 0 and 1. Okay, so this is sort of a one-row table. Let's, now that we've learned this notation, especially and or, there's your probabilities. What's the probability of, if you selected one of these gentlemen, that you would select the tall person? How would you find that? What would you add? So you'd add the 22 tall low earners to the 101 tall high earners out of 192. And you get 123 out of 192. And remember, you can leave it as a fraction, it doesn't have to be reduced. Now remember what this word means, what this symbol means, and. What's the probability that you get a tall person and a high earner? Yeah, just this one. There's no cells to add. But what would be the probability of getting tall or high? Wouldn't we add all of them except the short low arm? So 22 plus 48 plus 101 out of 192 gives us 171. Agreed. Okay. And again, you could have made those in, we could have used the decimals and answered all the questions. That's fine. Okay. I just happen to use the fractions. In my handwritten note or in my written notes, I use decimals, but either one's fine. Okay, so this kind of speaks to the addition rule. When we see the word or, that means add. Okay? And this specific type of notation, U, is called union. So if we unite two sets, we are bringing together all the elements in set A, all the elements in set B, and all the elements in set A and B together. Okay, so you add their probabilities together. So what, I mean, you think of unions, you unite. Or add together. Okay. Another way that we can show it, and we've seen these before when we talked about categorical data in the first unit, where we used a two-way table. Okay. So this is just another way of showing that that one row table on the previous page. So if it's presented to you like this, what would be the probability of H, which represents a high income earner? How would you find that? The probability of a high income earner. 149, because you would add these out of 192. So you can go straight to the sum of these two, because you're given the sum of the high numbers, and put that over the total, 192. Okay, this one you got to think about a little bit. Tall person and not a high earner.
1, 2.
Tall person and not a high earner. Yeah. Right? Because if they're tall, they have to be in here, and if they're not a high earner, it can't be this. So 22 out of 1. Tall person or a high earner. Well, there's all the tall people, right? There's all the high earners. So couldn't I just add these two together? But I know what you're thinking. You're thinking add these three, right? That's fine. That'll work. But here's another way you can look at it, and it answers some other questions. The total number of high earners, the total number of tall people, but I double counted this cell twice, didn't I? So if you add this and take away this, or you can add these three, you're going to get the same answer. But I just wanted to show you the add then subtract, because that's actually the probability rule, the addition rule. So we could go 22 plus 48 plus 101 over 192. Or we could take the total tall plus the total high earner, subtract the ones that were double counted, or tall and high earner. Both of these are going to give us the same answer. And that's going to be 171 out of 192. And the reason why I wanted to show you that is because that's technically the addition rule in probability. Okay? And this, by the way, you will always get it is on your formula sheet. So what we are doing when we find the probability of one event or the other event happening, we are finding the probability of A or B by adding. But then we are taking away the probability that they both happen together, because that was double counted. So like here, I'm adding the probability of T and then H, and then subtracting the probability of T and H. So that's how we get this formula. And going back to our Venn diagrams, you can take any two-way table and translate it or convert it to a Venn diagram. Okay? Like here, these would be like if our two events that we're dealing with are tall and high earner. These would be tall only, but not high earners, right? Because it's outside the high earner circle, inside the tall. So tall, but not high earners. In other words, tall and low earners. This would be tall and high, which matches to this. This would be high earners, but not tall. Okay? Or high earners, but short, which is this. And this is everything outside of tall and high, which is this one. So they are equivalent to each other. Some of these we've answered already. So you can either look at this, or you can look at this. Say, what's the probability of a high? Well, if you look at the Venn diagram, these are in high, and so are these. So if we use the Venn diagram, we would go 101 plus 48 over 192, which is equal to 149 over 192. If we use the two-way table, we just go, oh, well, here, the total high earners is 149 and 192. High earner and tall, well, you can either locate it here in the two-way table, or locate it in the intersection of T and H in the Venn diagram. Either way, it's 101 out of 192. What about high earner and not tall? So they're in the H, but they're not in the T. So 40. This one outside the H, be careful with this one. Right. You have to add 22 and 21. Everything that you see outside the H circle. You get 43 over 192. And then tall or high earner, well, we can just add these three. If we're looking at the Venn diagram. Tall only, high earner only, tall and high earner, put all those together. So notice the different ways you could be presented with a problem to ask to calculate probabilities. And one final way, and this is where the formula comes in really, is that you're just giving it in words. So a survey of all students at a large high school revealed that in the last month, 38% of them went to Taco Bell, 16% went to Chipotle, 9% went to both. Suppose we select a student at random. What's the probability the student has dined at Taco Bell or Chipotle? Well, to find the probability of Taco Bell or Chipotle, I have to find the probability that they dined at Taco Bell, have the probability that they dined at Chipotle. Now, remember, 38% of these that went to those weren't, it doesn't say Taco Bell only. Some of these may have been to Chipotle. Okay? Some of these may have been at Taco Bell. So what we have to do is we have to subtract away the overlap. And that's part of the formula. Because we assume that 9% that dined at both, we double counted them. Okay? So we have to take them away because we counted them twice. So it's just simply 38 plus 16 minus 9. Which is going to give us 45%. Okay? And one last thing is a modified formula when the two events are mutually exclusive. That means they cannot occur together. Okay? So they cannot both occur, they have no intersection if we draw them using a Venn diagram. And use the addition rule for mutually exclusive events, there's no overlap to subtract. So that's why we don't include minus P, A, and B, because there is no overlap. Okay, so we don't have to worry about the overlap, which is the probability of P and B, because it doesn't exist. Can you think of two events that are mutually exclusive? The probability of getting of owning a cat, or how about, yeah, the probability an animal is a cat and the probability an animal is a dog. True. Because if it was owned a cat and owned a dog, there's likely going to be some overlap. Right? Probability that you're a man probability that you're pregnant. Okay. There's another one. Anyway. Yeah, I use that one actually because we're going to talk about that when we talk about independent events, and that's the example that I use. Because they're definitely mutually